So if you listen to my previous page, I actually already worked through this. It says, suppose a single card is drawn from a deck of playing cards. Find the probability of drawing a 5 or a king. Our key word here is the word or. So we want to find the probability of a 5 or a king. To do that, we're going to find the probability of a 5 plus the probability of a king. The reason that we can do this is because 5s and kings are mutually exclusive. They have nothing in common. The probability of drawing a 5 is 4 out of 52. The probability of drawing a king is 4 out of 52. We put those two together, we end up with 8 out of 52, which simplifies to, use your calculator, 2 over 13. So what's the probability of drawing a 5 or a king? The answer would be 2/13. Let's continue on. It says 2 fair dice are tossed. What is the probability of rolling a 7 or an 11? So again, multiple times this section, this chapter, we've had to think about rolling 2 die and what combinations we can get with rolling 2 die. We add the pips of them together, the dots of them, the two numbers of them, and we see what possible combinations we have. You'll want to put this on your note card on the test because we do it so many times in this class, and it makes it a lot faster for you. I'm going to complete the table now. So now we look at this. It says it wants the probability of rolling a 7. So I'm going to look at my 7s on there. 1, 2, 3, 4, 5, 6 of the 36 spots are 7s. And now I'm going to look at 11s. There's 1, 2, 11s. Notice these have nothing in common. No blues are green and no greens are blue. So there's nothing in common. So if I want to know the probability of rolling a 7 or, give me one sec, the probability of rolling a 7 or an 11, that's going to be the probability of a 7 plus the probability of 11, because it's the word or, and these are mutually exclusive. The probability of rolling a 7 was 6 of the 36. The probability of rolling an 11 was 2 of the 36. Because they have a common denominator, we can easily add them to be 8 over 36. We use our calculator to simplify. We get a final probability of 2/9. Okay, one thing I do want to remind you of is if you remember, every single probability has to be between the numbers 0 and 1. Look at all the values of our fractions. Every single fraction we have gotten so far has been between 0 and 1. No matter what, if it's a question about probability, your answer has to be between 0 and 1. When you are adding things together, a lot of students mess this up, and they add up fractions that end up to a number bigger than 1. If you ever get an answer bigger than 1, you know you've made a mistake. Go back and check it. Most likely your mistake, in this case, if you got a number bigger than 1 is the probability of 7 and the probability of 11, for example. If we got a number bigger than 1, we either calculated the individual probabilities wrong, or we didn't realize that these are not mutually exclusive. And if they're not mutually exclusive, you cannot just add them together. Okay, let's look at the next one. It says, consider the experiment of rolling 2 dice. Let A be the event of rolling the sum of an 8, and let B be the event of rolling a double, the same number on both die. So how can we get an 8? Well, we've already seen that from the chart above. There's many different ways of getting an 8, but it looks like there's 1, 2, 3, 4, 5 different ways of getting an 8. How many different ways can you get doubles? Well, it's 1s, 2s, 3s, 4s, 5s, or 6s. But what do you notice? If you look at this, one way of getting an 8 is the same way as rolling a double, and that would be 2 4s. So these events are not mutually exclusive. So let's think about this. If I was trying to determine the probability of rolling a sum of 8 or a double, what would I do here? Well, look at the total possibilities. We know that there's 36 total possible ways of rolling 2 dice together, 6 for the first dice, 6 for the second die, and multiply them, or just look at the chart above that has all 36 options. How many distinct options do we have? Well, we have 1, 2, 3, 4, 5 options for the first. We have 6 options for the second one, but it's 5 distinct options because we can't repeat double 4s. So it looks to me like we would have 10 out of 36 total possible, which simplifies to 5/18. So how could have we gotten that without knowing? Because had we just done the probability of an 8, which was 5/36, and added to that the probability of a double, which was 6/36, we would have actually ended up with a probability of 11/36, which is the wrong number. So why weren't we able to just add them together? And what do? Well, the reason we weren't able to add them together is because these events were not mutually exclusive. They both had 2 4s. So what do you do when they are not mutually exclusive? Well, the idea is you take the probability of A, you add to it the probability of B, and then you subtract from it the probability of both, anything that they have in common. So for instance here, the probability of rolling an 8 was 5/36. The probability of rolling a double was 6 out of 36, but then we have to subtract anything they have in common, which was 1 of the 36. That would give us 5 plus 6 minus 1, which is 10/36, which simplifies to the 5/18, which we were able to get earlier.